Thank you everyone for being here. My second year back in Brno, first talk I've ever given here, so very nice to have the opportunity to talk to you all. If anybody here works in security, in IT security, please be gentle with me. I gave this presentation in config management camp, and I had people in the audience who were like, yeah, that's wrong, you could get by on that bit. So be gentle with me. This is not my primary role, but let's talk a little bit about me, what I'm here today, what I'm here to do. So, first of all, I am a senior technical account manager at AWS. Now, the link with Red Hat is, you can see there, I'm a published author on Ansible, so my first ever talk like this in front of a room was Ansible Fest in 2018, and I started writing books about Ansible then. I've been working sort of in the Red Hat space, Red Hat Premier Partner in London for about 10 years before I moved to AWS, so long history with the open source community and Red Hat. When I'm not geeking out over technology and that kind of thing, I do some esoteric stuff like Reiki, and I'm a dad to 2 boys on the autism spectrum as well, and we've got our youngest ever attendee for an IT security presentation. I think that's awesome. So, if you want to get in touch with me, ask any questions, follow up, you don't get a chance to get a question today, or if you're like me, you leave a presentation and then the greatest question occurs to you 5 minutes after you've left. My socials are all available through the QR codes that you'll see littered around the slides, so do get in touch. I'm very happy to chat, connect, that kind of thing. So, without further ado, my assistant, clearly. Okay, so we're going to go through a very, very brief canned history of secret management, why it's relevant and why we're here to talk about it today. I'm then going to introduce a tool that not many people seem to have actually heard of, but it's one of my little pet tools that I'm enjoying using at the moment. And then we'll go through a worked example and some lessons learned, next steps, that kind of thing. So fairly straightforward. The whole goal of this presentation is to give you a way in, a way to get started, a way to actually do this hands-on and go, okay, now I understand it. If you're like me, you learn through doing. And I hit some frustrations with this. I'll share them with you so you can see the pitfalls. You'll see code on the slides. You're very welcome to photograph it, but it's all on GitHub. There is a link coming at the end, so don't feel you've got to try and grab it as we go through the presentation. So, secret management, first of all. Now this, like anything in technology, this has been evolving for years, and it seems incredible to me to go back. I think it was 74, you could actually read the passwords in plain text in Unix in the password file. And that just seems incredible in this day and age. But we've kind of come from there. Unsecured secrets have always been a risk. And we've got ever-growing threats. You know, I come from London. We've just had 2 of our big retailers, Marks and Spencer's and one of the other, got hacked recently. You know, if your systems are not air-gapped, there's definitely a risk there. There's always going to be a risk there. I always say to, you know, my other half, when she's concerned about security, it's like, well, if you turn your computer off, you're guaranteed not to get hacked. I can tell you that one. And then, of course, we've got quantum around the corner as well. So what is secure today is not going to be secure tomorrow necessarily. And, of course, that's been the case for years anyway. So secrets do get pushed to GitHub. I've done it once and set off alarms in my day job because apparently we have automatic detection systems for people who accidentally push secrets there. So I learned that one the hard way. But I think we also live in a world where single factor is really no longer enough. I mean, it was for a long time, but static secrets, single factor, that kind of thing are really not the solution anymore. Now, obviously, I've been around Ansible for a long time, as I mentioned. We have Ansible Vault, so worth setting context with that. It's a great solution in its own right because it saves you, if you just want to do something really quick, hacky, on your own laptop, on your own machine, you can put these secrets in a vault. You're not storing them in plain text. They're in a form of encryption that outside of quantum is considered reasonably secure today. And I have known people who actually push the Vault files to GitHub. I don't personally because, you know, you'll forget they're there in 5 years. But the thing is, even if you do use Vault, even if that is the solution, you've got things like it's going to be secured by a single static password. If someone gets hold of that Vault, so let's say that you do publish on GitHub, rather, accidentally or deliberately, there's no brute force prevention mechanism. Someone can download it and just hit it over and over again and keep trying passwords until they get in. So it's a very sort of all or nothing. There's no role-based access control. There's none of the fine-grained controls that we would like to see in a modern technology system. Now, if you're using AWX, if you're using what was Ansible Tower, Ansible Automation Platform now, the controller in that, then you start to bring in some sort of secret management. And this is a big step forward because it brings in role-based access control. It moves the secret data away from the playbooks entirely, so you can actually store your playbook code in source control without thinking too much about it, without worrying too much about it. So it's definitely a step in the right direction, but it's an Ansible-only solution. And it's not that that's a bad thing, but we have systems all over that use passwords, databases, application layers, all that kind of thing. So there seems to me to be a requirement for something more. And the other thing, of course, with it is I'm not aware, if anybody is closer to the projects than I am, then obviously keep me honest here, but I don't think you can store any of the sort of dynamic or ephemeral secrets in AWX that you would use for things like the public cloud providers. So one of the things that's happened in the world of technology in general is that we have sometimes accidentally made things that were never designed to be secure, high-value targets. Think of SIM swapping for mobiles. The banks all made your login linked to an SMS message to log you in. So basically, the mobile phone providers suddenly became a security provider. They were never intended to be that. And your bank account has more passwords, more protection, more keywords on it than your phone account possibly does, or it certainly would have done in times gone by. Ansible is kind of the same. What you don't want is to have an Ansible control node, one centralized point in your network, which is a high-value target. And that's what it could very easily turn into. If you've got SSH keys, which will probably have root access across your network to all the machines, you've got all the credentials. Let's say you're setting up a database or you're an application layer to talk to it, so you've got the passwords for the database in there. You have created something that's like, well, if someone does get into your network, they don't have to really even walk around the network to find it. They just want to find the Ansible controller, and they've got everything they need to do whatever it is that they want to do. So let's not create this situation in the first place, basically. Now, that brings us to CyberArk Conjur. Now, most people have heard of HashiCorp Vault, and this is, for me, an analogous product. It's the same idea. Why did I pick this to play with? For me, it was simpler to set up. It uses technologies I understand and have worked with. I'm possibly a little bit dated in my approach, but we can discuss that in the Q&A at the end. But the great thing is, it's like so many solutions these days. It's on GitHub, it's open source, there are enterprise versions available if you need it. It's really, really simple to deploy. You can deploy a single node. I'll show you an architecture diagram in a minute. It's really easy to maintain, and it provides all the answers that we're looking for in terms of the problems that we've set out so far in this presentation. It's giving you role-based access control for secrets. It's giving you secure management for non-human entities. So we have the concept of machine credentials as well as human credentials. We have support in there for dynamic credentials as well. So there's a lot of important stuff in here. And it has native integration for a lot of the popular DevOps tool chains today. So I think this is a pretty neat solution. I've put the link here to it as well so you can go and explore it. Now this is how I've ended up playing with Conjur, just to start with. And what I like about it is you're not playing around with anything particularly advanced. I don't know how to back up an etcd setup, for example. I do know how to work with Postgres. I know how to back it up. So for me, this was really simple and straightforward. And this is actually what I've got in my home lab. So I'm using Docker. Postgres backend, Conjur app, and then some sort of proxy in the front which puts the SSL, the TLS cert on it, and that kind of thing. And then I've got my Ansible control node and whatever nodes I am controlling with it. Now, you can get Conjur set up and running very, very quickly. My setup in my home lab is actually based on the original code from CyberArk. The link is there. So it's the sort of thing, they've got a Docker Compose file, so if you know how to work with one of them, you can get up and running in 5-10 minutes. I just adapted that file for my own setup, but it's really, really easy to get up and running. And that was one of the things that I really liked about Conjur, was it's just so straightforward to get up and running and get going with it. Now, in terms of Ansible integration points, it has integration for both. If you're still on Ansible 2.8 or earlier, there is an Ansible role for it. However, there's a collection for 2.9 and later, so they've got catered for both. Now, there is a little bit more in the collection. Hopefully, most people will be on the collection version, on the later version anyway, but it's just to say that there is still a role available if you're on earlier versions of RHEL or something like that, and you need the earlier version of Ansible. It's there for you. When you've got Conjur up and running, everything is over an API. It's all secured over TLS, which is great. There is no GUI, unfortunately. So although it's running over HTTPS, and even if you navigate there in a browser, you will see a sort of holding page that says, I'm running on this address at this port. You can't configure it through the web browser. There is no GUI. So it's all CLI driven. You can use an API as well. Personally, I've only got as far as using the CLI, but I think the API could be really powerful if you started integrating this into your workflows, CI/CD, that kind of thing. The CLI itself is a self-contained binary written in Go. Again, it's on GitHub. The source is available. It's really, really easy because you just download it and run it, and it's about as complicated as that. When you've got this far, when you've got a working Conjur setup, then you can start working with policies. And policies in Conjur are written in YAML. So again, if you come from an Ansible background, this is going to be familiar to you. Obviously, it is a different syntax, as you can see here, but it's in YAML. We're not talking about sort of a shift to JSON or some other format. I've read a lot of YAML in my time around Ansible, so I appreciated that. And so what you would do, if you wanted to build up an example policy as a sort of test bed, which is what we're doing here in this presentation, you would start with something like this. So you would define at the root level, which is what's happening in here when you load this policy file in to Conjur, 2 policies within it. So the way policies are organized in Conjur, they're like paths in a file system. So you have a root level, and then you'd have /Ansible and /server. So 2 separate policies which serve different purposes. Then we start extending the policy to the control node itself. And there's a few different statements in here. There's actually 2 different examples built into this one slide. So the first thing that you've got at the top is we're declaring a layer. And a layer in Conjur is very much like a group. It is a way of grouping things together. But they don't use the word group because groups are actually something else in Conjur, just to keep life complicated. So without going into that in too much detail, we've got the layer. We're defining a host called Ansible01 for the sake of this argument. And then we're saying, put the host Ansible01 into this layer, so into this group. Grant that. We've also got a thing down the bottom called a host factory. And this is a very useful feature of Conjur that I particularly like. And what that's for is it's for quickly adding machines to Conjur. So let's say that you're running a CI/CD pipeline, you're doing some sort of automation or something like that. The idea of a host factory is that a human user or a CI/CD process, something like that, generates a short-lived invitation token. You then give that to the control node itself. It then uses that to ingest its own credential from Conjur. Now, the invite token is short-lived. The actual token that it gets for itself, so the machine credential that it gets granted by Conjur, is long-lived. So even long after the original invite token is expired, it remains added. Now, the great idea about this is, and the whole idea is, you might have multiple Ansible controllers for redundancy, just extending this little example here. What you would be doing is, rather than having to go back to this policy, so let's say we set up Ansible 02, if you wanted to add that by hand, you'd have to go back to this policy file, add host Ansible 02, add it as a member of the layer, and then reload the policy. It's not difficult, but it's fiddly, and unnecessarily so in a world where things are getting more and more streamlined, more and more automated. So the idea of the host factory is that we're saying the host factory lives in the same layer, and so anything that gets added through the host factory automatically gets an entry in here without you having to modify the policy at all. So it's a really, really simple way of adding multiple hosts. When you've created the control node itself, then the thing that you're going to want to do is define a policy for the server. So in this case, this is thinking of my target nodes, the things that Ansible is going to work with or set up. And so this is reasonably readable. You define some variables, which is fairly self-explanatory. You don't have the ability in these policy files to actually set the variables in the YAML. So there's no accidental leaving of secret data in a YAML file. You can only declare the variable names. And again, you can see the slashes in them. They're declared in a path-like structure, just like the policies are. You then create a group, which is what I mentioned. Groups are different from layers. So groups pull together layers, users, and other facets. Hosts, that's right. Hosts, users, layers go into groups. So they are like a higher level than a layer itself. And what we then have is a fairly readable statement, which is a permit, a grant statement, which is saying that all our variables are being allowed read and execute, so very much like a directory in a Linux file system, read and use, and that goes for the group secret users. And then finally, at the bottom, we're saying grant the group secret users, so that is this structure up here, read and execute all variables, to the layer /Ansible. So anything, put that into human terms, I'll rewind myself a little bit. What we're saying is anything, any machine that's in the Ansible layer, so Ansible 01, anything added through the host factory gets access to these variables. That's like the 15-second version of this policy. Now, I've mentioned there's no secret data in the policy, so that's very neat. You can't accidentally do that. You would use the Conjur CLI to actually push the secret data into Conjur itself. So commands very much like that. Again, once you know the syntax, very straightforward, very easy to do. And you can also retrieve the variables over the command line. So if you have something that doesn't natively integrate with Conjur, there are still ways to pull the variable data out and integrate it. Final step of getting your example environment up and running. So let's say, and reasonable assumption in 2025, you're using one of the Ansible releases after 2.9 that supports collections. To actually integrate the host itself, you would install the collection. Fairly obvious. It's not, unfortunately, a standard part of the Ansible install at the moment. You then need to create a certificate based on whatever you've set up as your TLS. So basically, it needs a CA chain that it can authenticate against. You can turn off TLS verification, as with most of these examples. Don't do it if you can avoid it. We then see us accessing the host factory to create the short-lived token that I mentioned earlier for the host, and we export the token as an environment variable. And when you've done all that, you put together a very simple playbook that declares the role and puts everything together. So you can see there it's looking up the host factory token from the environment variable. You could also obviously put it into this file as well, but the idea of putting it in the environment variable is you might want to run this on multiple nodes, so you don't have to vary the code per node to do this. So you would do that, you would run it in a fairly simple construct, and what this does is it runs locally on the node that you run it, and it sets up all the requirements. It pushes the TLS CA chain that I mentioned earlier into /etc. It basically puts everything together so that the Ansible control node gets that machine identity that I talked about earlier. And that gives it permission to access those variables that we set up. So, all of that, a little bit long-winded, but bear in mind that we're 20 minutes into a half-hour presentation, and I've really talked you through the entire one-time setup process for Conjur. So, and it doesn't take a lot longer out of the box to actually do this with the code. So when you've done that, you can actually, yes, sorry.
You have described it how to do it on one node. Can you do it also with Kubernetes? But it will be distributed in the Kubernetes cluster?
I don't know specifically, but short answer, yes, it's possible. I just don't know the technical details. Okay, I tell you what, can we do that question again at the end? Is that okay?
Yes.
Okay, great. I'll come back to it at the end. I think that's going to be better. Thank you. Okay, perfect. So if the one-time setup is complete, we can then create an inventory just like we normally would. And what's useful about this is we don't have to set up any SSH keys. We're not specifying any usernames, anything like that. This obviously is just my little example here. But the whole idea is the only thing we're putting in the inventory now is we're putting a host name, nothing else. Then we can define a playbook. And what I'm doing here, this didn't come out incredibly legible on the slides, but as I say, this is all on GitHub, so you can see it a little easier. We're setting some of the Ansible magic variables, so the host, user, and SSH password, and we're using the lookup plugin that we installed from the collection earlier to pull the variables from the Conjur server. And you can see there, I've left that in. We've got the validate certs equals true on there. You don't have to put that in, that's implicit. But I had that in there because I had some problems, which I'll share with you at the end of this, and I couldn't get the TLS validation working early on, so I had this in here for almost for debugging purposes. So I put it in there for those of you who are experimenting, particularly if you get up and running quickly with a self-signed cert, you probably want to turn this off. It's just going to make your life easier. Then we're doing some really simplistic stuff. We're just running some shell commands, but it's to prove that when we get onto the remote machine where we've pulled all the credentials from Conjur, that we can run commands, we can see what user we are, we can see what the host name is, and basically just a simple comforting proof that we are actually running the Ansible code on the remote node. We're not actually just doing it with smoke and mirrors on the local node. That's what should result if you run the playbook and everything works as planned. I'm not going to read you through some output from the Ansible playbook tool, obviously, but what's important here is what have we achieved? In doing this, we've got an Ansible control node with no static credentials stored on it. And obviously, this is only the start of what we're doing here. I'll move to next steps in a minute. But we don't have to set up an SSH key and store it on the host. We don't even have to put the username in the host because all of it gets pulled from Conjur, which is really, really flexible. The whole idea of this is that we're abstracting our secret management away from services like Ansible. So we're moving things such that the Ansible control node shouldn't be a high-value target, as I said earlier. And by doing this, the Ansible control node hopefully just contains playbooks and not actually a pile of passwords, keys, that kind of thing that you really don't want lying around. Conjur has role-based access control in it, which is great. In this simple example, we're not really using it. We're just using one user at the top level to do everything, but you can actually start to create different users with different permissions, which is really powerful. And as much as I have set up a really simple architecture here to learn the platform and to work with, it is scalable. It's cross-platform. The Go client is available for every major operating system you can think of. It integrates with a lot of products out of the box. CyberArk seem to have done a lot of work on integrating this with various platforms, which is really great. And this really is like a first step towards actually centralizing your secret management. And of course, what we're doing here is I'm showing the Ansible integration, but this is not something that has to be localized to Ansible. Which brings us to next steps. This is all hypothetical here. This is a nice simple example that you can go through in a half-hour presentation, but let's say that you want to extend this beyond today's example. You go beyond Ansible, which was what I said earlier about AWX. let's say that we've got a two-tier application, something simple like Conjur itself, although you probably wouldn't configure Conjur with Conjur because you get stuck in a loop. But you want to separate the host credentials from the application itself. And so maybe you've got a web tier, a database tier, the web tier wants to talk to the database tier. You could do things with the policy such that if the application is written to integrate with Conjur, it can pull its credentials for the database from Conjur itself. That means that you don't have to tell Ansible to pass the credentials to the node in the first place. So Ansible never actually even touches those credentials. And that means you can set up a policy that says Ansible cannot read those credentials because it doesn't need them. All it has to tell the application node is, this is the path to the variable that contains your credentials, go and read this. And if the other node does that, then we've taken, again, Ansible out of the equation where Ansible would have the high-value secrets either stored on it or accessible. Now, there are other things that you can do with this as well. It does support the ephemeral, the rotating credentials that you would find on platforms like AWS, and it does have rich logging as well. So you would put this into whatever your SIEM solution is, you would audit the logs on a regular basis to make sure that actually the people, the machines, the entities, because it's not just humans these days, that are supposed to be accessing the secrets are, and equally the negative case, that people who shouldn't be accessing them aren't accessing them. A couple of things I learned along this little journey if you want to give this a go for yourself and test the code out. First thing is the Conjur CLI. If you try and do this all from the Ansible control node, it will fail as soon as you've run that playbook where it runs the role to integrate the machine ID. The reason for that is that the Conjur CLI picks up the machine ID, which has lower credentials than the, let's call it the root user, who can actually set the variables. So you actually want a workstation to run the Conjur CLI on, an Ansible control node, and then whatever your Ansible targets are, the automation targets. So you basically need 3 nodes. That I sort of figured out the hard way when it stopped working. So that's just one to take note of. There might be a way around it with environment variables. I didn't get that far with it. The other thing that I found with this, and just to mention it here, because again, if you're doing this, particularly if you want to do this for learning purposes in your home lab or whatever, when I set this up, I put traffic in front of it as a proxy. I'm using Let's Encrypt for the certificates because it's nice and easy and I don't have to worry about validation errors or turning off TLS validation. I could not get the Conjur lookup plugin to actually validate the TLS, even though everything was set up and supposedly working. And there are 2 workarounds for this that I found running this on a Linux host. Either explicitly set the environment variable to point to the CA chain for your distribution. Where I was running it, it's there, but I know that varies sometimes from one Linux distribution to another. Or you can actually manually extract the CA trust chain for Let's Encrypt, so not for all the CAs in the world, but just for Let's Encrypt, and put it into conjur.pem in etc. If you do that, the TLS validation will pass, but for some reason it did not work out of the box, even though it would work for it with a paid-for TLS certificate. Again, never got to the bottom of that one, but something that will save you hours of pain, hopefully down the road. Now, as I mentioned, the code for this is all available. Everything that I've kind of talked you through here, the various steps, all the commands to run alongside the code are on GitHub. So the README files, I think, are pretty complete. Do have a look if it's something you're interested in. And I'm just going to pause just to let people capture that QR code. I'll put the slides up anyway on the DevConf site after this. I must confess they're not there at the moment, but I will put them up. So if anybody misses this, they'll be up there later today. And I think I pressed the wrong button. It's always good when your slides don't advance. There we go. Right. I think bang on, we'll turn it over to Q&A, and now we'll do it with the microphone.
You have
Hello? That's only for remote. Yes, my question is, you have shown us it, how to use it on one node. Is it also possible to use it on Kubernetes?
My understanding is it integrates with Kubernetes. I haven't looked into that. Learning Kubernetes is on my list of things to do, I must confess, but my understanding is it's capable, yes.
Hi, thank you for your interesting point of view for managing secrets. It's quite amazing and interesting, but I did not really get what's the benefit to reinvent the wheel and create the new solution instead of up and running HashiCorp Vault. It's presented, it's working, and why should I change the process? Please convince me.
I'm not actually going to convince you. I'm going to take the opposite approach. I certainly take your point, absolutely, and I'm aware that I'm at a Red Hat sponsored conference and there was an acquisition of HashiCorp has gone on and HashiCorp have Vault. This does the same function as HashiCorp Vault, so I don't think my goal here is to convince you to use this. I think my goal is to convince you to use a form of secret management. And for me, given my background, and you can judge me as you wish for this, I found Conjur was simpler and easier to deploy and use. Now that doesn't make it right or wrong or better than HashiCorp Vault. It's just my personal opinion on how to do this. Personal preference, basically. So, sorry, but yeah.
I assume the secret store is encrypted in some way. Do you know how it is encrypted and how it is decrypted on startup of Conjur itself?
I've not looked into the encryption. I do know it's encrypted, you're absolutely right. I don't know the technical detail of that. Oh. There's one more down the front.
Regarding the startup of the service and the encrypted store, do you have to enter some kind of passphrase when starting the service, so there's no automated start or restart of the Conjur service, right? Because that's how it is with Vault and the derivatives.
I set this up longer ago. It's left my brain.
Yes, but probably it will be like that because of the encryption.
There's got to be
of the
something.
database.
It'll be document. So that link that I shared earlier, to the CyberArk Quick Start demo, it's all in there basically. So there's certainly more examples in there. But yeah, it's a good point. Thank you.
Thank you.
One more question regarding secret. What about memory? Are the secrets in memory encrypted, or if they are encrypted, are they rotated?
That's a really good question, actually. I don't know the answer to it, unfortunately. My confession is I haven't dug into the technical implementation of CyberArk. I have taken some stuff on faith, but
the question was
is your question about where the passwords are encrypted in memory, is it in Ansible control node or in the Conjur? I know in Ansible control node they are not, right? So the moment you load it into a variable, obviously it is decrypted, it stays there in the memory. You can go pick with a profiler or a debugger and you will get it. In Conjur, I don't know.
Hey, just one question. I saw
Sure.
that at the beginning there was a setup, so you move the token and set up a token to all the managed nodes of Ansible, right?
Mm-hmm.
That means that there must be some kind of rotation of that node or like periodic refresh, right?
yes, yeah.
And that's something that you have to take care of yourself because like maybe it was like too quick, but I guess you need to set up like your own periodic refresh of that token, right?
So again, although I don't know exactly how it works, so the machine credentials are maintained, I know that I'm out of time. Very quickly, I know that you don't have to manually intervene on them. So whatever it's doing to keep the credentials refreshed is automated. I just don't know the technical implementation.
So, thank you everyone, and thank you to James for a nice talk.
Thank you very much.